The following demonstration is conducted in a controlled environment for the purpose of evaluating AI behavior and improving safety. Some examples may include sensitive or explicit content. EtherLab Guardrails is the enforcement layer for text and image moderation. In this walkthrough, I'm going to focus on how the product is actually configured and operated, not just what it does at a high level. On the home screen, you get the operational snapshot immediately: credit spend, token volume, request volume, per guardrail latency, and the blocked versus passed mix for both prompt guard and media guard. So before you even drill into policy, you already have a quick view of throughput, performance, and enforcement behavior across the system. This is how the NSFW industry preset is structured. For this preset, explicit content is allowed, while categories like bestiality, CSAM, scat, gore, graphic violence, hate speech, illicit content, public figures, sexual violence, self-harm, terrorism, and violence are blocked. With this preset, we're starting with a strong baseline that already handles the clearly unacceptable categories. As we'll see later on in this video, given how we've set up these policies, you will still have flexibility over how aggressive or permissive the final experience should be for your own users. That matters because moderation is always balancing safety, security, and user experience. The strength of EtherLab Guardrails is that we do not force that balance into a single blunt preset. We give you a clean baseline and then let you tune the system so it matches your application, your risk profile, and the user experience you actually want to deliver. So instead of over-banning by default or rebuilding policy from scratch, you get a modular starting point, strong, where the risk is obvious, flexible where product context matters. Now let's get into guardrail settings. This is the main place where you define policy and tune how the system behaves. The recommended way to use this is to start with the NSFW industry preset, which gives you the baseline safety layer first. From there, you build on top of it using blocked content and allowed content. Those fields are freeform, which is important. You are not writing brittle rules or forcing everything into a fixed taxonomy. You can describe policy the way you would describe it to a human reviewer. What should be blocked, what should still be allowed, and what context changes the decision. Once that policy language is in place, then you use the tuning controls. Reasoning mode controls how deeply the system analyzes the request. In practice, moving from low to medium to high tends to increase the risk assessment, but it also handles boundary cases better. Risk tolerance controls the broader risk profile, and threshold override lets you move the final cutoff directly when you need finer control. So the normal workflow here is start with the preset, add blocked and allowed policy in natural language, test real examples, and then tune reasoning, risk tolerance, or threshold override until the results line up with the behavior you want. As we discussed in the last section, this approach lets you improve both your user experience and security at the same time. Mathematically, this means you are reducing both the false positives and false negatives at the same time. When we discuss the log section, we'll see additional ways to boost performance. Now, let's look at prompt guard. The main thing to pay attention to here is how policy definition and reasoning depth interact. I'm starting with the NSFW preset along with the high reasoning mode, but I have not added incest to blocked content yet. On this first example, the result comes back compliant. That is expected. The prompt is clearly incest, but the system has not been told yet that incest is part of the custom blocked policy for this configuration. If I run the same input multiple times, you may notice that the exact threat score can move slightly. That variance is intentional. It is part of how the system avoids letting any single guardrailing bias dominate the result. In practice, that gives a better false positive versus false negative trade-off overall. So the exact score may drift a bit run to run, but the more important signal is the overall decision pattern once the policy is defined. Now I'll add incest to the blocked content and rerun the tests. As we can see, the result now becomes non-compliant. Adding contextual bespoke policies is that easy. Now, let's move on to our second example. Do you have any idea what the system should come back with here? I'll give you a second. So, it turns out that the two main characters in Supernatural are brothers, so this should be blocked from the policy control we just added, but before it even gets to that compliance check, it's blocked by our deepfake detector. And notice that the surfaced rationale emphasizes the public figure policy. That is expected. A single request can violate multiple policies at once, and the returned rationale may surface one of those policy violations more prominently than another. Operationally, the important thing is that the request is correctly identified as non-compliant. The third example here is a contextual one. It never directly names the family relationship, but the intent is still there. If you asked a human reviewer what the user is trying to do, they would likely say this is still incest based on context. That is the same kind of reasoning PromptGuard is applying here. It is not just matching explicit terms. It is evaluating likely user intent from the wording. So the practical workflow is start with the baseline preset, add the custom categories you care about, and then test both direct and indirect phrasings. That is how you verify not just that the system catches the obvious version of a request, but that it also catches the intended meaning behind it. The next example contains nudity and a sensitive moderation edge case. Up to this point, we've been looking at PromptGuard, which handles text inputs. MediaGuard is the same operating model applied to images. You still have the same policy controls, the same freeform blocked and allowed content, and the same tuning controls like reasoning mode, risk tolerance, and threshold override. The difference is that now we're evaluating an image instead of a prompt. Let's run this anime image through our system with the normal NSFW preset. With these settings, the image comes back non-compliant. The reason is simple. This is a young-looking female character whose age is ambiguous, and our system tends to block these kinds of examples by default. In fact, if you asked 10 people on the street whether the character depicted here was under 18 or over 18 years old, you'd probably get no consensus. As with PromptGuard, repeated runs can move the score slightly. That variance is intentional. It helps prevent anyone guardrailing bias from dominating the result, which improves the false positive versus false negative trade-off overall. Now, let's continue that same analogy and instruct the system the way we would instruct a human reviewer. I'm going to tell it, young-looking anime characters, if you are not sure on the age, allow the image. The point is not that the ambiguity disappears. The point is that we are explicitly telling the system how we want that ambiguity resolved for this application. With that instruction in place, the image now comes back compliant on low reasoning. If I move that same exact image to medium reasoning, the threat score jumps and the result flips back to non-compliant. And at high reasoning, it rises again and stays non-compliant. So this is the practical meaning of low, medium, and high. Low is the most permissive. Medium is a stronger default. High is the most conservative, but it also does the best job on ambiguous edge cases. The normal workflow is write the policy first, then run the same example through low, medium, and high to see where the boundary lands. Now, if the policy wording is right and the reasoning level is right, but the final cutoff is still a little too strict, that's where threshold override comes in. Let's set it to something else. Since the medium reasoning score usually lands right around that boundary, that same example can flip back to compliant without changing the policy itself. So threshold override is how you fine-tune the operating boundary after you've already decided on the policy and the reasoning level. One implementation detail here. If you want the richest rationale output, that currently comes from high reasoning mode. And one last implementation detail for MediaGuard specifically, latency is not just model inference. Data transfer matters too. If you resize images client-side before sending them to us, you can reduce I/O overhead and improve end-to-end latency. The settings here are resize proportionally, so the max long edge is 768 pixels. Use bilinear resizing, force the image to RGB, and send it as an optimized JPEG at quality 70. That keeps the payload small without materially changing the moderation result. The last thing to look at is guardrail logs. Once you've tested individual cases in PromptGuard and MediaGuard, this is where you review how those decisions are actually landing over time. Most of this page is fairly self-explanatory. Each row shows the guardrail type, the input, the blocked content, the allowed content, the threat level, the final result, and the timestamp. So if you ever want to understand why something passed or failed under a given configuration, this is the first place to look. At the top, you can filter by guardrail type and by result, and if you want to review things outside the product, you can export the logs directly to CSV. On the far right, you also have the feedback controls. This is another lever available to you as the end user. If you see an example that looks correct, you can mark it as good. If something looks off, you can mark it as bad. We use that feedback to continuously tune the guardrailing stack for your specific use case. Over time, this effectively results in a system that becomes more secure and more aligned with the user experience you want. Mathematically, both the false positive and false negative rates will be reduced. Right now, the only number that we are returning is the threat level. But we're also rolling out a more complete logs view that will include a confidence signal, more detailed logging fields, and improved filtering. We're also adding prioritization the logs so that the most critical or ambiguous cases are surfaced first rather than requiring you to manually review everything. So the practical workflow is define the policy and guardrail settings, test representative edge cases in Prompt Guard and Media Guard, and then use guardrail logs as the operational review layer once the system is in production.